Hello. Today we're going to talk about Topic 4, Section 14, Variance. So, we know that models are really important and useful, all right, but to make one that represents a real life event is difficult, okay? Just think about the equations they have to use to predict the weather. Lots of things can affect the weather, and if we make a variable for each of these things, that can make a very complex equation. All right, but if we know how these variables are affected, then we can adjust our models accordingly. I'm better with examples. All right, so let's do linear transformations. Okay, so of a single variable. So for instance, we have a standard dice. Typically, our standard dice is 1, 2, 3. That is a terrible 3. It's going to bother me. 3, 4, 5, 6. All right, the probability of each roll is, well, of any roll is 1 out of 6. So, how do we find the expected value? Well, hopefully you remember this. It's 1 times 1, 6, plus 2, right? All right, so the expectation of rolling just a regular die would be 3.5. Okay. Well, what would happen if I take the dice and I add 1 to each of the values? So it becomes 2, 3, 4, 5, 6, 7. All right, so we essentially have B. We're adding 1 to each X. Well, what that does to my overall is literally just add 1, right? My original expected value was 3.5, and now it's 4.5. Here its results if I actually did it by hand. All right, what about the expected value of doubling everything? So now A is 2. All right, we're literally doubling all our X values. So 2 times X. So it should just double our expectation. Well, let's do it by hand, right? 2 times 1, 6, right? For every single value, we get 7, which makes sense. Oops, sorry, didn't mean to have that there. Okay, so let's find the variance now. Luckily, you don't need to know the formula. Wonderful. All right, your calculator can do it for you. So let's use our calculator. Let's see. These are the values you're going to get. And let me write it out. So for list 1, you're going to put down your possibilities for rolling a dice. So 1, 2, 3, 4, 5, 6. In list 2, you're going to list the probability of each. So 1/6. Put that in each of your lists. And then you're going to do second variable stats. So in your calculator, you're going to go to stat calc two variable statistics, list 1 and list 2, calculate. There's your standard deviation, 1.707. That's what I got here. My variance is just that number squared. All right, and that's all you have to do for variance. All right, so now let's look at what the variance is with each of these. All right, so go in your calculator and change your first list and see what happens to your variance. So again, remember that the original one is, or the original standard deviation is 1.7, but remember calculations, you always look at variance. So the original variance was 2.9. So we do this one in our calculator. Oh, we get 2.9. Okay, because when we add or subtract, okay, this makes sense because we added, add and subtract doesn't change your variance. Okay. So now when we double it, well, that probably should change my variance. How does it change my variance? All right, well, we doubled it. Okay, well, that's more than 2 times that variance. Okay, almost, oh yeah, 4 times. Okay, so here to change your variance when we doubled x, we're going to square that number and multiply it times our variance. And that's how we got 11.67. Okay, well, approximately. Okay, so now let's do multiple variables. Okay, so instead of just rolling 1 dice, okay, I'm going to keep that dice the same normal 1, 2, 3, 4, 5, 6 on it. All right, but now I'm going to do 4 dice and add them all up. So what's the mean and the variance? Well, the mean is where we literally just add them 4 times, right? We've got 1 dice plus 2 dice, 3 dice, 4 dice. So it makes sense that the average would just be 4 times. Now for the variance, you would literally just add them up as well. Okay, so there we get our variance. Okay, so let's do another example. So here we're going to roll the dice 3 times. Then you subtract your second roll, or 2 times your second roll, and then you add your third roll. So what can I expect my score to be in the end? Right? If I'm trying to bet that I'll have a certain amount in the end, I want to know what I should expect. So let's start with the expectation. All right, so that's some crazy weird looking formula. Essentially, that means whatever I did on the inside, I do to the outside. So 3 times the expectation minus 2 times the expectation plus the third expectation. And they all have the same expectation because they're all the same dice. Well, an unbiased dice. All right, then we do the same thing for variance. However, you got to remember with variance, you have to square the number that you are multiplying. So instead of doing just 3 times, we do 3 squared. -2 is -2 squared. And of course, 1 squared is just 1. So the variance changes to this, which means the standard deviation is the square root of that. Okay, that's how we can show it mathematically. Okay, so now let's see if we can get unbiased estimates, or what we have, or if our estimates are unbiased to represent the population mean and variance. Okay, so if I'm rolling 2 dice, all right, I want to see if the mean of those 2 dice represents, all right, my roll represents the mean of all the other sides. Okay, so I want to see if this is unbiased. Okay, a good representation. All right, the actual mean of a 6-sided die is 3.5. All right, so what if I roll a 4 and a 5 and I get 4.5? Is that a good estimate of my actual mean? Okay, so let's look at this. All right, some notation you want to know that when you do a sample standard deviation, you use this, sigma. When you use the population, ooh, this is not right. That is your sample. Sigma is your population. Ooh, my bad. All right, so let's calculate the mean of the means of the rolling 2 dice. So these are all your possible values. You add them all up. You divide by, let's see, there's 36 of them. Let's see, you should get 3.5. Okay, so now we're going to calculate the variance. Okay, so the variance of each die, all right, is written in there. So if we calculate the average there, we should get 1.4583. Okay, so that's the variance. Now, 3.5 is a good estimate of the means, because that is how you get the mean, right? You add them all up and divide by how many there are. We want to see if this is a good estimate of the standard deviation. Well, the actual variance, I'm sorry, this is variance, I said standard deviation earlier. The actual variance is 2.916 repeating. So how do they compare? All right, hopefully you noticed that's just half of this one, right? So that is, not roughly, that is 1/2. All right, now if I was rolling 3 dice, okay, so if I was rolling 3 die, then my comparison, my sample standard deviation to my actual variance, I'm sorry, I keep saying standard deviation, your sample variance compared to the actual variance would be 2/3. Okay, rolling 4 die, all right, that fraction would be 3/4, right? Rolling n die would be n minus 1 over n. Okay, so using that, okay, we can adjust it, right? We know that our sample variance, so our sample variance over our population variance, that's standard deviation variance, is going to be equal to n minus 1 over n. So we do some finagling. We move that stuff around. We get n over n minus 1 times the sample variance is going to equal the population variance. And that's what we're going to use here. Okay, so that's my explanation of this formula. Okay, so now use this to find an unbiased estimate of the population variance. Okay. Collect your information. We know we have 50 items. Our variance is 12.3954. We plug it in. Bam. That's our unbiased estimate for the variance of the population. That's all we got to do. All right, so now let's look at this. So now let's calculate an estimate for the variance of the population using this data. All right, so for this one, you need to start by finding that mean, right? Because we're going to be doing the difference there. So we calculate the average. So 13 times 0 plus 22 times 1, right? We're doing the frequency times the number of siblings. All right, so we get the average to be 1.23, blah, blah, blah. Don't round that number, but then you would take the difference between every possibility, so number of siblings, minus the average, square it, times the frequency. Whew. And that's what you got to do to find your variance. Okay, so that would be the estimated variance. If it asked for the standard deviation, all you would have to do is square it. All right, so hopefully this makes sense. The manipulation of variables and how I can adjust things. All right, all our transformations. If you've got any questions, just come see me in class.